A few decades ago, paleontologists uncovered some very unusual fossils in China's northeastern Liaoning province. These fossils included one of the first relatively complete specimens of Sinosauropteryx, a feathered dinosaur from the early-late Jurassic period. But it also had something else. It had impressions of feathers preserved on its tail, and when researchers carefully cleaned those rocks away, they revealed not just any feathers but a cluster of long, pointed feathers that were arranged in a Quetzalcoatlus-like fan. This wasn't the first time these kinds of quills had been found. Sinosauropteryx had been described just a couple years prior, back in 1996, and it already had feathers. But the new fossil was special because this individual was clearly related to theropods, the group that includes Velociraptor and its close relatives. So seeing these quill-like feathers on the dino's tail suggested that this kind of plumage might have been widespread among theropods. Hi, I'm here with Minute Earth, and scientists think that is likely because these particular feathers may have helped keep their tails from getting too unwieldy as they evolved to run, jump, and fly. Now there are tons of other feathered dinosaurs, but this fossil stands out because it helped researchers learn how and why feathers evolved and how different dinosaur groups used them. To get this info, they turned to what's called Paleontology, the study of fossilized pollen and spores. Okay, yes, it does involve a lot of plants, but trust me, this is relevant. You see, paleontologists are really good at looking at tiny things and understanding how they're put together. So after the tail quills were discovered, one researcher who specialized in pollen figured she could probably figure out how they were attached to the dinosaur. Her name is Corina Brussate, and she works at the University of Edinburgh. She and her colleagues went to the fossil site where the original Sinosauropteryx was found and collected some rock samples from around where the feathered dino was discovered. Back in the lab, they examined thin slices of the rock under a microscope and found fossilized pollen. But more interestingly, they saw these little bumps that looked an awful lot like the base of a feather. They compared these structures to modern birds and found that they matched up with the attachment points for feathers that are anchored to a bird's body via a central pivot. From this, they concluded that dinosaurs probably used the same system. And while that doesn't sound super surprising, this was really important because it meant that studying the impressions left by feathers in rock could tell us how those feathers worked. After all, if each feather was attached to the body via a central pivot, then the angle at which each feather was embedded in the rock would indicate the angle at which it grew out of the animal. And that can tell us whether the feathers were used for display or for insulation or steering or a whole host of other things. In fact, by recreating the 3D environment in which the dinosaur once lived, researchers can determine how the wind would have blown across its body and through its feathers. That can tell them how efficient the feathers were at capturing air and generating lift, and therefore whether they might have been used for gliding or even powered flight. But feather-bearing fossils are rare, so when Brussate and her team came across another collection of possible theropod feathers, they were excited. But this time, instead of digging them out of rock, they had to dig them out of amber. See, in 2009, paleontologists found a relative of Ankylosaurus in amber in the northern part of China's Gansu province. The fossil is known as the Mofeng Bird or the Mofeng Ankylosaur, depending on whether you ask Brussate or the local press. And it has a ton of feathers. Because the fossil is so well preserved, it shows that feathers weren't the only thing this dino had. It also had scales and even claws. And while the previous analysis of the Mosasaurus showed that it had feathers, it didn't consider how the feathers might have been attached. So Brussate and her colleagues took a closer look, specifically at the shape of the bases of the feathers. In modern birds, the base of a feather is made of barbs and barbules, which branch out from the central pivot point. So the researchers scanned the amber-enclosed fossil with a synchrotron X-ray beam. And thanks to differences in density between the various tissues, the scan generated a detailed map showing where the feathers were attached to the dinosaur. They also used microcomputed tomography to digitally reconstruct the fossil, allowing them to make precise three-dimensional measurements. And when they did this, they found that the Mofeng Ankylosaur's feathers were inserted at an angle similar to modern birds. This means that they had central pivots, which enabled the dino to adjust the angle of each feather individually. But the study revealed something surprising. The Mofeng bird's feathers had asymmetrical barbs, unlike any modern bird. Asymmetrical barbs are thought to be advantageous for flight because they allow for more precise control over how the feather generates lift. But this dino was definitely not a flyer, so it makes no sense that it would have had asymmetrical feathers unless, of course, it was a swimmer. So the research team reconstructed how the water would have flowed over the dino's body based on the angles of its feathers. Their model suggests that the Mofeng bird's feathers would have functioned as paddles, helping it steer itself through the water, which means it likely spent quite a bit of time in water. This is supported by the shape of its skull and teeth, which seem to have been built for catching fish. This also explains why the Mofeng Ankylosaurus has feathers. All dinosaurs likely had some feathers, but many of them probably didn't look like modern birds because they grew and shed feathers multiple times per year. This dino must have molted twice between the ages of 2 and 4 months, and most of its adult feathers were probably replaced once per year, so it looks like it was always kind of seasonally unfeathered. And because feathers grow out of scales, not skin, scientists think this dino started growing feathers when its scaly ancestors didn't. And since it was amphibious, it used its feathers for swimming and display. These are just 2 examples of how advanced imaging techniques are being used to answer questions about dinosaurs. And it's not just about what the techniques reveal about the dinosaurs themselves. They also help researchers understand how the world these dinosaurs lived in has changed over time. For example, this recent study of the Mofeng bird has led to new questions about whether other dinosaurs lived part of their lives in water, or whether this was a unique adaptation of the Mofeng bird. Ultimately, this research highlights just how much there is to discover about the ancient world, even if we've seen these dinosaurs 1,000 times before. So thank you for watching this episode and for supporting our work. We wouldn't be able to uncover these fascinating stories without you. Our own personal Mofeng bird